The next step is we will choose the function u. We will choose the function u such that this part is equal to 0. Okay, so we considered y as a multiplication of two functions. Now the next step is to consider this part dv over dx plus p times v is equal to 0. Then when we do so now we choose v such that dv over dx plus p times v is equal to 0. Now we find that this dv over dx is equal to minus p times v. Next we will get that dv over v is equal to minus p times dx. Then we integrate, we take the integral, what we get is ln v is equal to minus the integral of p times dx plus some constant c1, or you could write simply ln c1, any constant. Next you will take the exponential on both sides. You get v is equal to some constant c1 exponential minus the integral of p dx. Okay, next so we have all of these choices implies that dv over dx plus p times v is equal to 0. We take the solution when v simply with c equals 1, that is exponential minus p dx. Okay, so now the next step is when we take this value of v, what you get finally. Remember our equation. The equation is u times dv over dx plus p dv is plus v times du's over dx is equal to q. Now we have seen that this part is equal to 0, so what remains is this part, v times du over dx is equal to q. So now what you get is, so you will get, now we could calculate the function u. The function u, you know that v is a known function now. It is simply, v is simply the exponential of minus p dx. Since this is a known function, now v also is a known function. So now we calculate u. So this leads to du over dx is equal to the function q of x over the function v of x. Remember that v is never equal to 0 because it is an exponential of something. So next Next we take the integral on both sides. What you get is u of x is equal to the integral of q x over v x dx plus some constant c. When we substitute this formula, what you get is now you substitute this into our function. Remember that u is equal to the function v times the function u. So now it will become u is equal to v of x times the function u, which is the integral of qx over v of x that we did, plus a constant c. Now the final solution will become is v of x times the integral of q over v dx plus a constant c times the function vx. Okay, now I will give you an example so you know how to apply this this solution. The students who were present in the last lecture in Wednesday, did we do these steps of the resolution of a first order differential equation?
No, it is.
Rayla, could you answer please? I didn't hear your answer. So the last thing we did is how to reduce the equation. The equation is reducible to separable variables.
Yeah, that's the last thing.
So thank you. So now we continue with the following example. So we have an example